Hi, this is Wayne Odegard, and I'm with Aviation Laboratories. And this morning I'd like to talk a little bit about why we do oil and oil filter analysis in aviation engines. So the first thing we should know is that when we look at oil and we look at oil filter, we're trying to proactively find abnormal wear. We're looking for abnormal wear, that kind of wear that's going to create problems, either mechanical problems that are going to require a major fix or overhaul, or safety problems, so that we can catch those things before they become serious, before they become deadly, before they become expensive. So that's what we try to do with oil analysis. But there's a difference between oil analysis and oil filter analysis, and it's important that we understand what that difference is. With oil analysis, we just take a sample of oil and we look for elemental metals, transitional metals mostly. We're looking for iron, we're looking for copper, we're looking for chromium, and because it's elemental analysis, we don't necessarily know where those are coming from in the engine. We just know that they're coming from the engine. We like to say every engine makes metal, which is true. You're going to have a baseline of these wear metals in your oil all of the time. What we're trying to detect is abnormal levels of those wear metals. Obviously, if we're looking for changes in wear metals in oil, we're also interested in the trend, because the more data points we get, the more obvious the changes become, and the more dramatic the changes become if they're abnormal. So it's important for us when we talk about oil analysis to recognize that the trend is the most important part of that, and to get a good trend you should do it at least every oil change. Okay, so let's talk about filter analysis. With filter analysis, we're not looking at the oil now, we're looking at the debris that's been captured in the filter. And the debris that we capture in the filter, some of it we can see, some of it we can't see. So the same purpose applies. We're trying to find abnormal wear in the engine. But whereas with oil analysis, we're looking for elemental wear metals, with filter analysis, we can see actually solid. We can see the chips that are coming from the engine. But I'd like to make one point about filter analysis. There's a difference between the filters in a piston engine versus the filters in a turbine engine. In a piston engine, because the pore size of a filter, a typical filter, is 30 or 40 microns, that means the holes that are in the media in the filter itself, a lot of the wear metals flow right through that filter. The smaller wear metals flow right through that filter. So for us, the piston engine oil analysis is the more important analysis. A turbine engine is different from that. Because the turbine engine isn't exposed to the same kinds of combustion byproducts, dirt, debris that a piston engine sees, the pore size of a turbine filter can be much smaller. It can be 4, 5, 6 microns in size, in which case most of the early warning signs for abnormal debris get caught in the filter. So when you look at oil analysis for a turbine engine, you don't really see a lot. The data is in the filter. So when we're talking about pistons, we like to do oil analysis every oil change. When we're looking at turbines, we can still do oil analysis, but it's really important for us, because most of the data is in the filter, that we do filter analysis as well. But in either case, what we're trying to do is identify abnormal wear before it becomes an expensive or safety type problem for you.